Okay, so no point hiding from it anymore. We'll tackle this head on, right? The incline plane problem, the famous problem of having a slope like this, putting a box somewhere over here and have it slide down. Tell me everything you know about it, right? How long does it take to get down the slope if I tell you a certain angle like this, all right? So, but what I want to show you is really there is, and this is a theme for the whole of today, there's no new concepts. This is one of the special lectures where there's zero new concepts. It's really an application of everything else we have done already. And you can see, you can be convinced, hopefully, that we are going to use all just Newton's law and all the good old kinematics equation. They'll tell us everything we need to know about motions that we're going to look at, right? And I'm going to, this is probably the most important thing you'll learn about solving problems-wise, technique-wise, is what I call the universal strategy for solving problems with forces. Okay, solving any problems with force, you follow these 3 steps. So I call it the universal strategy for force problems. Okay, so any problem the moment you smell and you sense that it has to do with force, you do these 3 things, whatever the situation. Okay, first, draw a free body diagram, and you know very well now how do you draw it. You ask 2 questions. You ask what's touching it and what's not touching it. What's touching it will provide you with a contact force, and what's not touching it provides you with a non-contact force. This is just a mnemonic to remember it, but remember to fill in the fine prints, fill in the parts where I'm not saying the full sentence, right? Really, I'm asking, well, what's touching it really? Anything that's touching it will provide a force. If my hand is pushing it, if there's a string pulling it, right? Either a tension or a push or whatever, there is some force on it. The surface will provide a normal force and a friction, all those things you've seen and heard many, many times by now. You're not touching it, again, remember, fill in the blanks, fill in the blanks of the rest of my sentence is what's not touching it. I can't speak today, not touching it, yet providing a force, all right? So what's not touching something, yet providing a force, and the only thing we learn about is weight, right? The gravitational force, right? So what's not touching it, yet providing a force is the non-contact force of gravity, and this is going to be the only non-contact force you'll see in this whole course. When you move on to 3B, you will learn another one. In fact, you will learn 2 other new ones. We'll leave it to you to figure it out then. But throughout this whole course, there's one. And also, there's a nice question to think about. How many non-contact forces do you think there are in the universe? Right? I'll tell you the answer. There's 4. There's only 4 fundamentally non-contact forces in all of the universe that we know of at this stage as of 2021, right? So if you, if you're curious, you can look that up what they are. We're not going to divert too far away. But the first step, let's go back to the strategy. Draw your free body diagram. Make sure you don't suddenly invent any forces that are not supposed to be there. Don't miss out any forces that are supposed to be there. All right. Then you write out Newton's second law. And when you do that, you ask yourself, is this a 1D problem or a 2D problem? Are the forces, are all the vectors, do they all lie on an axis? So you ask, all lie on an axis? Or if it is, it's a 1D problem, nothing needs to do more on it, just move on and solve it. If it is a 2D problem, if things do not lie on an axis, then you need to go and resolve the diagonal forces. We'll see what that means. We'll do a lot of this today. That's kind of our goal, okay? So far, a lot of them, almost every problem we've done is basically one-dimensional. Today, we're basically gonna finish off with looking at all the 2-dimensional variations of it. But if you know how to resolve vectors, which you've learned from the first week, these should be no problem at all. And then you move on and solve the equations, right? So all of them, all of these things that do with forces these 3 steps are almost crucial. All right, so let's apply it to here. Let's see what we can find. Let's make this concrete. If I have a 100-meter height kind of slope, and you for example sit on a skateboard that is 100 meters tall and as a slope of 30 degrees, let's say, how long will it take you to go all the way down here, right? So you go like, well, what's gonna make you go down at all if I start off at rest? And let's start with the simple case of friction, no friction, frictionless problem like that. All right. So if there's no friction, you start off at rest. What's gonna make you even accelerate? Because if something, Newton's first law said if you stay at rest, you stay at rest. Nothing changes, right? Yeah, then you know the answer to that is if there's a net force on it, right? So go ahead, draw the free body diagram for me on this object, on this box. Remember, no friction, and then we'll deal with cases that there are frictions. If you are way ahead of me, go ahead, try to solve for the time over there. And if you struggle, we'll go through that step by step in the next video.